Wardenclyffe Tower. You walk into a cleared field and the air tastes like metal. A domed structure hums, and a single light bulb hangs above you, glowing with no visible wire. That is what Nikola Tesla promised, literally free power sent through the air. He built a tower on Long Island in the early 1900s and called it Wardenclyffe. The idea was simple-sounding and giant-sounding at the same time. Tesla thought the Earth itself could carry energy if you hit it at the right frequency. He used high-frequency coils and giant domes to tune into the planet like a radio. Give the ground the right push, and a town could light up without a single cable. Tesla demonstrated wireless sparks and small transfers in his labs. Back then, people in suits called it visionary and dangerous. J.P. Morgan funded part of the dream, until he pulled out when the returns looked uncertain. Construction slowed, and the tower was never fully working. By the time the structure was torn down, the world had moved to wired grids and radio waves for communication. So what really happened to the secret plans? After Tesla died, some papers vanished, and others were seized. Fans say the best notes were lost. Skeptics say the physics never matched the hype, and the losses were financial more than conspiratorial. The truth sits between genius and failure. Basically, what Tesla tried anticipated modern wireless charging and resonant coupling, but not the global free energy he dreamed of. Still, the idea of sending usable power through the ground sounds impossible, and that is why the story refuses to die. The tower stands now only in pictures, and in a question that will not leave you. How close was he to a working system, and who decided it was time for the wires to stay? He kept detailed sketches and notebooks. Engineers who later studied those papers found careful notes about resonant frequencies and huge coil designs. Some experiments in the lab did transmit small amounts of power without wires. Those were real. They worked at a distance, measured in feet rather than miles. The big leap from a glowing bulb in a lab to lighting a whole city was where the math and the hardware broke down. Money evaporated. Investors wanted returns they could bill. Regulators and new technologies moved the market toward wired grids and radio signals. The tower sat unfinished and was torn down. That is the plain history. But then the rumors begin. After his death, officials cataloged some papers and took others. Fans point to missing notebooks and to pages that never surfaced. Skeptics point out that extraordinary claims need extraordinary proof. Tesla was brilliant and also given to grand forecasts. He loved neat theories that do not survive full-scale engineering. Today, we have echoes of his dream. You place a phone on a pad and it charges through magnetic coupling. Engineers beam power short distances to sensors and to drones for brief recharging. The physics that makes that possible is the same family of ideas Tesla chased. What he overestimated was scale, and what he underestimated were economics and control. So was a working global transmitter ever lost or suppressed? Or did a genius chase a vision no one could afford at the time? The answer matters. It asks who owns the future of energy and what gets buried when money and power change hands. The question hangs there. Searle effect generator. You step into a dusty workshop, and a ring of magnets spins under fluorescent light, humming like a bee. For a few followers, that hum was proof. For most engineers, it was a red flag. Here is what is solid. He described stacks of rollers and rings set in a precise magnetic pattern. He filed patents, and he gave public talks, and he staged demonstrations that drew curious crowds. In the demonstrations, the device turned and lights glowed. That is the part that keeps people talking. Supporters say the machine produced excess current and even floated. Critics point out two simple facts. The demonstrations lacked independent controls, and the measurements were never replicated in a lab with outside observers. Patent papers describe arrangements of magnets and conductors, but patents do not equal validated physics. So, What are we left with? A genuine idea that failed replication, or a clever show with tricks never fully explained? The science community says conservation of energy still stands. The most plausible technical explanation is that the device amplified shifting magnetic fields and produced local currents, but not free energy. That would explain lights and spinning with hidden inputs or clever wiring. Now the human story thickens. The inventor receded from mainstream labs, and legal battles followed. Documents are spotty. Admirers claim missing blueprints and secret tests. Skeptics say those are the usual claims when evidence is thin. You are left holding two images, one of a crowded workshop and a faint humming promise, the other of a rulebook called physics that refuses to be broken. Searle effect generator. You step closer to a spinning ring, and the lights in the room dim, then glow like they have been fed by something unseen. That hum convinced a small group. They saw lights and slow lifts, and they felt certain physics had been bent. Here is the clear part. The device uses concentric rollers and magnet rings arranged in a precise pattern. When the assembly turns, it creates changing magnetic fields. The inventor claimed the pattern made current appear and lift follow. He filed patents, and he showed machines in public. Now the messy part. Demonstrations had no independent observers, and measurements were never replicated in a controlled lab. Engineers measured local currents and stray wiring in several filmed demos. The simplest explanation is not magic. Changing magnetic fields can induce currents. Clever wiring and hidden inputs can make lights glow. Ion effects and motor coupling can create apparent lift. That explains why mainstream physics remained unconvinced. But perspective matters. Devotees swear they saw levitation and uninterrupted power. They point to missing blueprints and to visits by curious officials. Skeptics point to court filings and abandoned projects, and to the way human hope fills holes where data is thin. The truth sits between showmanship and real invention. So what do you believe? Was there an overlooked breakthrough hidden by secrecy and ridicule? Or was this the usual pattern where clever demos mask ordinary inputs and wishful thinking fills the rest? The question is not idle. It asks who decides what counts as proof and who keeps the notebook safe. A distant hum fades. The workshop door clicks closed. Philadelphia experiment. You stand on a damp pier, and a gray hull sits calm when a witness swears it vanished into thin air, then reappeared miles away. That image is why the story will not die. Here is what we can check. The claim centers on the destroyer escort, called the Eldridge, and a date in October 1943. The man who told the tale to the wider world was Carl Meredith Allen, who wrote Strange Letters in the 1950s. His account is dramatic and hard to forget. Now the evidence. The ship logs and war diaries are public. They placed the Eldridge on convoy duty in the Atlantic that autumn. Naval historians and the Navy itself reviewed the claims and found no sign of teleportation experiments. That is the plain record. There is a real technology worth noting. During the war, navies used degaussing to hide ships from magnetic mines. Degaussing changes a ship magnetic signature, and that is often confused with invisibility in later retellings. Later advances in stealth and cloaking in science fiction also feed the imagination. So why does the myth endure? Some say government secrecy and misplaced documents hide truth. Some say a prankster and a thirsty publishing market made a great story. People who follow or sell the tale point to missing files and odd Navy memos. Skeptics point to eyewitness confusion and to the power of rumor. Which explanation feels more likely, and why does a modern audience still prefer the spooky version? The answer is not only about facts, it is about what we want belief to do for us. The pier is empty now, and the echo of that hum keeps calling. You watch an archivist lift a rusted box from a shelf and blow dust into the light. Inside are faded deck logs and neat typed orders. Those pages quietly end the big claim. They show the Eldridge on convoy duty in the Atlantic in October 1943. Not in the Philadelphia yard, in some vanished moment. That evidence did not stop the story. Carl Meredith Allen wrote letters with strange detail. He mixed real wartime jargon with dramatic scenes of sailors fused to bulkheads. Those images traveled into a book decades later, and then into movies and TV. Stories need an outlet, and the tale found one. Scientists and naval historians point to real, less spooky technology. Degaussing cables changed a ship magnetic signature and protected against mines. That led to later misunderstandings and to imaginative leaps. People who wanted secret weapons saw teleportation. People who wanted mystery heard teleportation. There is a lesson here about memory and motive. Wartime secrecy makes fertile ground for tall tales. A prankster can become a prophet. A missing file does not prove a cover-up. It proves a story hole that people will fill with desire. Fans of the myth say officials hid experiments. Skeptics say witnesses misremembered, and sellers amplified a good story. So what matters more? The documentary page you can hold, or the image that makes your skin prickle? The answer shapes how you judge the rest of this list. The archive door closes, and the hush stays with you. What lost discovery feels real enough to risk your belief? Schauberger's implosion technology. You stand on a riverbank, and the water spirals away from your boots like a small, furious world. Victor Schauberger watched that motion until it spoke to him. He saw a pattern in vortices, and believed that spiraling motion held a gentler kind of force he called implosion. Here is the simple explanation. He argued that spiraling water concentrates energy inward. He built turbines and log flumes that used vortex shapes to cut friction and move heavy timber with less power. He sketched disk machines and a device called the repulsine, and described how swirling fluids could produce lift and unusual effects. There are facts, and there are stories. The facts include patents for vortex turbines and written designs for water transport. Those inventions worked in practical tests. The stories are louder. During the 1930s and 40s, some people in power took an interest. Wartime Germany investigated many odd ideas, and some of Schauberger's work was tested in restricted sites. Scientists warn against the poetic language he used about life energy and implosion. Engineers say vortex designs can improve efficiency, but they do not overturn physics. Enthusiasts point to reports of prototypes and to claims that Allied forces seized documents and machinery after the war. Historians find evidence of some confiscation, but no proof of a ready-made anti-gravity engine. So what do we have? A naturalist who learned from rivers, and a handful of useful machines that were real. We also have murky wartime custody of papers and a later myth that fills the gaps. The river keeps turning. Far from the forest, an Ohio garage would soon host a very different promise about water and fuel. You follow muddy boot prints into a shed where brass fittings and spiraled pipes lie on a bench. Those practical pieces mattered most. Several vortex turbines and log chutes built from his designs worked as claimed. Villages moved timber with less effort, and test reports praised efficiency. He filed patents that show real engineering insight. Those records are not fantasy. Then come the whispers. Wartime officials took interest, and some parts and notes changed hands. After the conflict, a few documents were cataloged by occupying forces, and some machines were moved for study. That is documented. What is not documented is a clean trail to a perfect anti-gravity engine. Historians who dug through archives found evidence of seizure and of interviews with technicians. They did not find a finished flying machine. The split in views is human. Engineers applaud clever vortex turbines and roll their eyes at claims that water suddenly breaks physics. Devotees hear the missing pieces and fill the gap with a larger possibility. People who want suppressed marvels see a pattern of secrecy. Scholars answer with caution and single-line evidence. So, what should you hold on to? Keep the concrete turbines, the patents, the reports of restricted testing. Be wary of sweeping claims that live on secondhand testimony. The story shows how a respectful study of nature can generate useful tech and also myth. Far from the mountain river, a simple garage in the United States would soon become the center of a very different water promise. Stanley Meyer Water Fuel Cell. You stand in a cluttered garage, a car hood open, and a small glass cell bubbling as a man promises the engine will run on water alone. That promise is the heart of the story, and it hooked investors and television cameras in the 1990s. Here is what he claimed in plain words. He said his cell split water into hydrogen and oxygen using special electrical pulses, and that it did so with far less energy than ordinary electrolysis. In his telling, the process was tuned so the water released fuel without paying the usual cost in electricity. There are real documents, there are patents describing plate stacks and control circuits, and there are videos of a demonstration car that the public saw. That is what keeps belief alive. But now, the messy facts. Independent tests failed to reproduce the claimed efficiency. Experts pointed out that the energy to make hydrogen must at minimum equal the energy you can get back, according to basic physics. A court case in 1996 concluded that investors had been misled. Then the human drama. Supporters say blueprints went missing, and that the inventor died suddenly in 1998 under suspicious circumstances. Skeptics say the timing feeds a classic suppression story. Engineers say thermodynamics still applies, and that clever electronics and pressure tricks can make a showy demo without a game-changing discovery. So, what do you hold on to? The patents and the publicity, or the independent tests and the court record? The garage light hums and the glass keeps bubbling. Somewhere in that noise is the answer, and it is not yet settled. You watch court transcripts being placed on a table and legal stamps landing like small, decisive gavel blows. The court record is blunt. Experts tested the cell and found no net energy gain that would break the rules of conservation. That finding changed investor confidence and reputations overnight. Patents remain a piece of the puzzle. The filings show inventive ideas about pulsed circuits and cell geometry. They document clever thinking, not a proven engine. Patents protect concept and novelty. They do not prove the miracle promised on television. Then comes the human weight. The inventor argued fiercely in public and privately. He blamed suppression and shadowy interests. Supporters tell stories about missing blueprints and a sudden death in 1998. Those claims fuel the myth and keep the hope alive in online forums and small conventions. Engineers explain the core physics simply. To make hydrogen, you must input energy. You cannot get more energy back than you invest, at least with current known chemistry and engineering. Clever electronics can make demos look efficient for a short time, but under controlled measurement, the numbers tell the real story. So where does that leave us? Hold the things we can check, keep the patents, respect the demonstrations that were public. But accept the court findings and the limits spelled out by basic physics. The missing papers and the tragic death make a better story than a broken experiment ever could. That is why the garage light flickers with both possibility and caution. A glass cell still bubbles in memory. The question that follows is not whether we want change. It is who decides when proof becomes truth. Thomas Townsend Brown, Electrogravitics. You step into a dim lab, and a crackle of ozone hits your nose. Large capacitors sit on tables. Wires snake like vines. A plate glows, and a model shudders upward on a thin stand. Here is the simple claim. Arrange an uneven pair of charged plates. Push huge voltages through them, and the device will produce lift. He called it a coupling between electricity and gravity. He built models, and he filed patents in the 1950s and early 1960s. Public demonstrations showed motion and curious behavior. That drew the attention of hobbyists and a few military engineers. The inventor pushed the idea hard. His writing mixed experimental notes with big predictions about future craft. Then the careful tests began. When engineers moved experiments into vacuum chambers, the lift vanished. In air, the effect matched what is called ion wind. Charged particles accelerate and push on the surrounding air. That creates thrust. It is a real effect. It is not gravity bending. NASA and independent labs examined similar devices and found no evidence of gravity control. Patents recorded design ideas. Replications revealed practical thrust from ion flow rather than mysterious new physics. Still, the story resonates. A few engineers swear they felt something different. A small number of documents hint at restricted experiments. Enthusiasts point to those notes and to ambiguous military interest as proof that something was hidden. So, what do you trust? The clear vacuum data or the charged claims remembered in lab lore? A crate of metal parts sits in a hangar, stamped with a faded label and a lock. The sound of a single key turning is all that separates belief from evidence. You watch a hangar door open and a crate slide out on rollers. Inside are curved plates and labeled drawings that someone once hoped would change flight. He scribbled notes and filed patents that captured his experiments. Those papers matter. Engineers set the models in a vacuum chamber to test the claim. The motion stopped when the air left. That result points to an ordinary cause. Charged particles move and push on surrounding air. That creates thrust. It is called ion wind. You can feel it if you hold your hand near a running device. The push is real. The push is not gravity changing. Military logs show limited interest and small-scale testing. That is true. It is also true that no clear operational system emerged. NASA studies and independent labs measured the effects and reported ion-driven thrust rather than new physics. The evidence sits on paper and on graphs and on instrument readouts. Still, people remember a different scene. An eager engineer smiling at a model that lifts. A patrol of curious officers asking questions. A few technicians who later spoke in quiet tones about prototypes taken to storage. Those human moments feed the idea that something more may have been present. So, where should your trust sit? With controlled experiments that fail to show gravity coupling, or with memory, hope, and locked crates that whisper of unseen tests? The answer shapes how you view the rest of these tales. The hangar door closes and the truck idles, loaded with metal and paper, and a rumor that will not stop rolling down the road. Bessler Wheel. You push through a packed room and see a large wooden drum turning by itself while nobles and engineers take careful notes. The air smells of wax and wood. The wheel kept turning for long demonstrations, and people marveled. He claimed a clever arrangement of weights and levers made it run without fuel. He published a report. He invited witnesses, and he offered sealed tests where the wheel ran inside a locked box. Some attendees signed affidavits, and some wealthy patrons supported him for a time. Those public attestations are remarkable. They made the story spread across courts and salons in the early 18th century. A prince even paid for a workshop and for secure demonstrations. That gave the wheel credibility that no ordinary trickster would easily get. Modern science looks at the claim differently. The laws that govern energy and work today rule out a true perpetual motion machine. Historians and engineers suggest hidden power sources, concealed springs, or staged tricks. In some reconstructions, a wound spring or a hidden operator could explain continuous motion while preserving the seals in plain sight. Then there is the man himself. He kept secrets. He refused to show the inner mechanism to do what he promised. He died with only cryptic clues and a reputation split between genius and fraud. He burned material before he died and left puzzling notes. So what do you believe? Do the witnesses and sealed rooms prove a lost physics? Or do they tell a different story about showmanship, patronage, and the hunger for endless power? While questions like that sit in dusty archives, gears would be found 2,000 years later under the sea and change the way we think about real ancient technology. Besler Wheel. You stand back as attendants unbolt a case, and the wheel turns steadily for an hour, while nobles murmur and scribes note the time. That steady motion made witnesses swear they had seen the impossible. Contemporary accounts recorded sealed demonstrations and signed affidavits. Patrons paid handsomely for secrecy and for the promise of endless power. Besler published a report and offered to explain his method for a price. He guarded his secret jealously and then destroyed some materials before he died. Modern engineers asked a simpler question. How could a machine run without input and still obey the laws we test in every workshop? Reconstructions show where hidden springs or wound mechanisms could mimic perpetual motion for hours. The seals and boxes that impressed witnesses could hide human cleverness or stored energy. The simplest mechanical explanations fit the eyewitness records without rewriting physics. Historians add context about patronage and spectacle. In an age hungry for novelty, a show that promised free energy bought protection and trust. When the inventor refused full disclosure and then burned pages, the story grew larger than the wheel itself. That pattern repeats across history. So what should hold your belief? The sworn witnesses and sealed rooms, or the physics and plausible concealed drives reconstructed centuries later? Both matter. Both tell us why some inventions become legend, while others enter textbooks. Underwater, far from 18th century halls, bronze teeth of gears waited in silt for 2,000 years. They turned a very different kind of clock, and they would force historians to rethink how advanced ancient craftsmen could be. Antikythera mechanism. You hold a crusted bronze fragment in your hand, and you can feel the weight of centuries. Diver ropes creak, and a sponge diver pulls a loaf-sized chunk of metal from a wreck in 1901. No one expected gears. Here is what it is. Inside that dirty bronze were dozens of tiny interlocking gears. Turn the main shaft, and the gears move in a precise dance. The device could predict the positions of the sun and the moon. It could predict eclipses decades ahead. It used gear ratios to model cycles that astronomers of the time tracked. Scientists did not accept this at first. The idea that ancient craftsmen could make complex gear trains that rival medieval clocks seemed impossible. Then modern technology arrived. X-ray tomography and three-dimensional imaging let researchers see inside the corroded pieces. They counted gears and mapped teeth and rebuilt gear trains in software. The evidence was clear. This was an ancient mechanical computer, so who built it? Was it a workshop in Rhodes or an astronomer in Alexandria? Inscriptions on the mechanism point to Greek months and technical labels. Scholars argue about links to known astronomers, like Hipparchus. Others point out that similar mechanical skill does not appear widely in the archaeological record. The device proves that advanced mechanical thinking existed long before the medieval clock. It forces a hard question. If a civilization could build gear computers 2,000 years ago, why did this level of technology vanish for centuries? The sea keeps its treasures, and the next chapter will visit another buried mystery. You watch technicians rotate a virtual replica on a screen, and the gears fall into place exactly as the scans predicted. Each tooth and axle answered questions and raised new ones. The device mapped lunar cycles and the complex irregularities in the moon motion with mechanical elegance. That showed not clever guesswork, but precise astronomical knowledge. Scholars cheered and argued at once. Some argued it came from a Rhodes workshop where clockmaking and astronomy met. Others argued for a wider tradition of mechanical skill that we have only glimpsed. Inscriptions in Greek months and technical labels point to a Hellenistic mind. The debate continues because the artifact sits in fragments, and because written descriptions are scarce. The impact changed history books. For 2,000 years, scholars thought advanced gear trains were a medieval innovation. The mechanism forces a rethink. It shows that complex mechanical modeling existed long before the medieval clock. It also shows how knowledge can be concentrated in a few hands and lost when workshops disappear or trade routes collapse. That loss matters more than mystery. When craftsmanship vanishes, so do techniques that could seed future inventions. The mechanism proves advanced thinking once existed and was forgotten. It proves that missing does not always mean impossible. Under the weight of silt and salt, those bronze teeth waited silently. Far from the calm of the Mediterranean Sea, a thunder would later fall on a Siberian forest and spark myths that joined science and speculation. Tunguska event and Tesla death ray. You stand on a snowy plain, and the trees lie flattened like fallen pencils for miles and miles. On June 30th, 1908, a massive blast ripped through a Siberian forest. Eyewitnesses saw a bright trail and a violent shockwave. Later expeditions measured the pattern of fallen trees and the lack of a crater. Scientists concluded a meteoroid or comet fragment exploded in the atmosphere. The airburst explains the damage and fits the physics we can test. Then the myth arrived. Decades later, writers and enthusiasts looked for dramatic causes. Nikola Tesla had spoken in the 1930s about a teleforce weapon, a particle beam he said could defend nations. He described a device in interviews and in unpublished notes. He sought funding, and he never produced a working prototype for public tests. After Tesla died, some papers were collected by officials. That fact and Tesla's dramatic reputation fed speculation. People asked a blunt question: could an experiment or a weapon have caused Tunguska? The short answer from historians and physicists is no. The timing and the documented travels of the object match a natural impact. There is no credible evidence linking Tesla to the explosion. Still, the story persists, because it is a powerful image. A genius with secret plans, lost notes, and a remote fiery event makes a clean, shareable narrative. Which is more likely? A cosmic rock exploding high in the sky, or a human-built beam that reached across continents? The plane stays quiet as the sky keeps its secrets. Far from Siberia, wartime Europe would soon birth another strange rumor about a bell-like device. Tunguska event and Tesla death ray. You walk among snapped trunks lying like matchsticks, and the silence feels deliberate, like a scene someone swept clean after a storm. Scientists who first studied the site measured patterns in the trees, looked at blast damage, and read eyewitness accounts. The result points to a meteoroid or comet fragment exploding in the air. It blew apart at altitude, creating a blast wave that flattened the forest without leaving a classic impact crater. Forensic studies and later analysis using tree rings and satellite data support that natural explanation. The physics add up. The pattern of burned trees and the distribution of shock match an airburst and not a single directed beam. That is the scientific payoff. Then comes the temptation to connect dots. Nikola Tesla talked in interviews in the 1930s about a teleforce weapon he sometimes called a death ray. He described a way to project concentrated particles or energy to stop aircraft at a distance. He sought funding, and he wrote notes and patents related to charged particle ideas. He never demonstrated a working system in public that independent scientists could verify. After his death, some papers were catalogued and others vanished into archives. That gap feeds speculation. People ask a simple, dramatic question: could a lost experiment or secret weapon have caused Tunguska? Scholars answer with a simple counter. The timing and the physics match a cosmic object. No credible document links Tesla to the explosion. Still, the story persists because it mixes a dramatic event with a dramatic figure and missing pages. The Siberian plain stays cold and quiet. Far from there, wartime Europe would later whisper about a bell-shaped device that promised even stranger physics. Nazi bell. You walk through a concrete ruin where the plaster flakes off in long strips, and the air smells faintly of oil and old rope. The idea is simple and terrible at the same time. A bell-shaped device that hums, spins, or produces strange fields. A machine said to bend gravity or to open other doors in time. The modern story begins with one source. A Polish writer published a book with claims based on alleged interrogation transcripts and shadowy testimony. Later, a journalist picked up the thread and linked the bell to anti-gravity research and zero-point energy. From there, the tale grew into a web of names and alleged secret projects. Here is what is known. There are no primary Nazi documents that mention a device called Die Glocke. Archives searched by serious historians do not contain the transcripts the initial author described. Allied intelligence and post-war reports catalog many experimental projects. They do not list a bell that bends physics. That does not stop the story. The myth grows for reasons that are human. Wartime secrecy breeds rumor. Real projects like centrifuges and experimental labs create plausible scaffolding. Wanting a dramatic explanation makes improbable stories memorable. So consider the choices. Accept a modern account that cannot show primary sources. Or accept the simpler explanation that the story is a late fabrication built from the fear of secret weapons and the real shadows cast by wartime research. The concrete bunker stays cold. The bell, if it ever existed, leaves behind only whispers and a record of speculation. What do you want to be true when truth is so easy to romanticize? Nazi bell. You stand in a cold archive room, and a file folder slides out, like a secret that does not want to be a secret. Researchers ask for the records the original author claimed to have. They find references to centrifuges and to experimental gear, but not a transcript that proves a bell that bends physics. Serious historians searched Nazi archives and Allied reports. They cataloged many advanced projects and rational wartime research. They found documentation about rockets, jets, and nuclear efforts. They did not find evidence of a bell-shaped machine that manipulated time or gravity. That absence matters because archives ordinarily hold the kinds of records the author said existed. So why does the story persist? First, wartime secrecy left space for rumor. Second, real experimental machines like high-speed centrifuges and odd laboratory gear create plausible-sounding scaffolding. Third, the human love for dramatic explanations prefers hidden wonders to slow recorded process. A single dramatic claim with missing sources is easier to remember than a pile of technical reports. Conspiracy thrives where paperwork is thin and emotions run high. The Bell story shows how modern books and television stitched fragments into a grand myth. That does not make the tale true. It makes it powerful. You close the folder, and the room smells faintly of dust and coffee. The bell, if it ever rang, left no ring to measure. Across these 10 stories, a pattern appears. Some inventions were real and lost. Some were demonstrations that failed replication. Some are myths that answer a need. As you consider which is which, one question lingers. What would you do if a real, impossible technology resurfaced tomorrow? Let me know in the comments.